Hi everyone, we are going to be working with integer division today. So as you can see here, we have a problem of 27,692 divided by 23 laid out. But first, before we get into that, we are going to go back to our definition of division and refresh ourselves of what that truly means. So division is distributing some amount of stuff equally among a certain number of groups and counting how many is in one group. So as you can see here of our long division problem, we have 692 divided by 23, and over here in block form we are showing the same exact thing. So right here we have a display of two super rods, 7 super cubes, right here, 6 flats, 9 rods, and 2 singles. And we want to divide all of these blocks down here equally into our equal amount of our certain number of groups. As you can refer back to the definition, we're going to be looking at our biggest place valued number, which is our 2, and ask ourselves, can 23 go into 2? Well, no, it can't. So we have to look over here and go from the highest to the lowest place value points. And right now what we're going to do is break down our super rods and divide that from our super cubes. So what we're going to do here is break these down and into super cubes, representing 10 super cubes. So now what we have here, a total of 27 super cubes, and that is from us breaking down our super rods. So we can go back here to our long division and say, okay, 23 did not go into our 2 place values, so we had to break it down to the next place value. So we can write a 0 right up here, and 23 does go into 27 once. 23 going into 27 once is the same as us saying, well, we took 27 of our super cubes and we gave 1 to each of our 23 groups. So in this case, we are able to write that down here. And next, what we want to do here in our long division problem is take 23 times 1, giving us 23. And that is the same as us saying that we took away 23 of our super cubes and distributed them equally among our groups. So what we're able to do over here is know that we've already taken away each of these 4 super cubes as well as the 3 up here, leaving us with a total of 4 super cubes. And over here you can see that we have 27 minus 23 giving us a total of 4, because we have already given those 23 super cubes away equally into our 20 groups. What we're going to do here is notice that we only have 4 super cubes left and break them down, but however, we cannot divide them equally. We need to break down our super cubes into a smaller unit. And now this is where we look at our flats. And because we could not divide them equally, this is why we're breaking them down into our next unit that is smaller. So once we bring down these cubes and breaking them down into flats, we are going to have a total of 40 flats here, including our 6 flats that we've originally started with. giving us a total of 46 flats. So we've taken these away and broken them down into flats. And over here in our long division problem, that is the same as bringing down our 6, because we've also brought down our supercubes. As we've mentioned before, we are only looking at each unit at a time. So now what we're going to do is ask ourselves, how many times can 23 go into 46? Well, that is 2, giving us 46. And over here, that is because we needed to break down our 46 flats, meaning that each of our groups are given 2 flats, because 23 goes into 46 equally twice. So we are going to give each group 2 flats. But 46 is giving us 0 left over, which is the same thing as saying that we have equally distributed all of our 46 flats. And this was because twice is how many times 23 went into 46, equally giving each group 2 flats. So we can see here that ending up with our 0, we've already used and distributed all of our flats. Quick note as well, the reason that we did not do 12 times 23 is because we, like I said before, we are only looking at a certain unit at a time. In this case, we were only looking at our flats units. And because we were only focusing on one, in this case, we couldn't do 12 times 23. Okay, so now moving on to our next place value in our problem, which is our 9. And we are able to bring this down. And over here, we are looking and focusing on our 9 rods. However, we do not have enough rods to divide equally into our groups. So we are able to put 23 going into 9 0 times, because that is just us saying that we do not have enough rods to divide down equally into our certain amount of groups. And that's where we got the 0, because over here we as well cannot divide 23 by 9. So that gave us 0. The reason why we did that is because we could not give all of our rods away to our 23 groups. So now is look at our rods. Well, and we know that we cannot divide them equally into our 23 groups. Therefore, we are going to have to break them down into the next smallest unit, which is our singles. So we are going to take these rods and break them down into nine groups of 10 singles. So in this case, we have gotten rid of our rods because we have broken them down into singles, giving us a total of 92, because we have 9 groups of 10 singles here plus our 2 that we've originally had. So we can look back over here at our long division problem and bring down that 2. Because bringing down that 2 is the same as saying that we've broken down our 9 rods, because we couldn't originally divide them equally. So we ask ourselves, how many times can 23 go into 92? And that is 4 times. That is also the same as us saying, how many of these singles can we give to each of our groups here? In this case, it is 4. So, long division problem, noting that 23 is able to go into 92 4 times. That's the same as us saying that we are able to equally distribute 4 singles to each of our groups. And now that we've distributed each of our 4 singles to our groups, that is the same as saying 23 times 4, giving us a total of 92, equaling out to 0. And that means that we have used all of our singles, and these as well. So we've used all of our singles. And that leaves us with a final answer of 1,204. And as you can see in our block form, that matches with our answer as well, because we have 1 supercube, 2 flats, 0 rods, and 4 singles, giving us 1,204 in block form as well, and giving us a matching number. 1 supercube, 2 flats, 0 rods, and 4 singles, giving us 1,204 as well. And that's how you break it down with cubes as well.